Like we're hiring contracts. Yeah, I'm sure she can find somewhere in space. Oh, like maybe she's. There's basically no room for like our. Yeah. Right now it's and they feel out like yeah. So I know. They probably have to move across the bay. Like across the walkway. Little like tiny narrow. Everybody excuse me. It was me. I mean, I see Roman's arrived before me and had the same issue. To avoid that.
Hangouts absolutely kills my do with it.
Hello, everybody. Welcome. Thank you very much for coming tonight. Great. Thank you very much. Welcome. Thanks for coming tonight. Thanks to Skills Matter for hosting us. We've got some great talks tonight. We've got Keith Woods on first. He's going to talk about maintainable single-page applications, I reckon. Something like that. Just had a baby 2 days ago, so he probably hasn't slept. And we've got Graham and Alexi talking later. So big thanks to Skills Matter. Couple of announcements. Red Badger's hiring, got to say that. Otherwise I get in a lot of trouble. We've got the conference coming up in March, and I think the tickets are going on the 7th of October, so look out for that. We've got some great speakers, including Dan Abramov and Christopher Shadow and Lee Byron and Ben Elput, so it's going to be really, really good. If anybody wants to submit a talk for that, that would be great. The opening for submissions shortly, not sure when. When? November. Anyway, so let's get on with it. Thank you, Keith. Cheers.
Pardon? Did it die again? Is it okay?
All good.
My name is Wood. I'm going to talk to you today about building complex SPAs in React and ESP. So I work for a company called Adaptive Financial, and we build real-time trading systems for investment banks, hedge funds, commodity houses, that type of stuff. So I've kind of been in this space for the past, I don't know, 5-10 years, building these type of real-time push-based systems. Here's an example of the type of app that we would build for our clients. So this is Reactive Trader Cloud. This is actually an open source reference implementation. We've released it adaptive. You can download the code and check it out. But from a business point of view, this is kind of like an FX trading application. So a trader, for example, will have an app like this open all week long on their desktop. And they want to exchange some currency, for example. So they select a particular currency pair, maybe one in the top corner, GDP, JPY, type in a notional amount, see a price they like, execute it. Then the bottom here in the trade blotter, you'd see a trade notification and your positions would be updated there. So it's kind of the type of app, like I said, it's open all day long, it's push-based. This particular one could run in a browser, but typically we'd run in like something like Electron or an OpenFin, which is kind of an Electron variant. So it's like a desktop app. Users don't really know that it's kind of a HTML variant. That is where I've spent most of my time building these type of apps. Quick note about the reference implementation. On the back end, it's kind of using an event sourcing architecture with many different microservices deployed out to the cloud. But today I'm going to talk more just about the front end and kind of some of the techniques I've used on the front end to kind of manage complicated state. There's also a sample in the ESP code base, which is this agile board. It's just, we'll touch a little bit about this in the app. In the talk today, sorry. The first app is kind of a big reference implementation, and sometimes it's a bit too much to take in. This is a lot more cut down. It's just a very simple, like, you know, have epic. I have a workspace for an agile board, for example, and I can add an epic. Epics have stories. You can do stories. It's just a very simple kind of concept with some hierarchical data. So it's easier to demonstrate the concept than a massive trading application. Okay, so this is the agenda I'm going to go through today, and I'll start off defining what ESP is. So ESP is a pattern for managing complex state. So it's something that I came up with a few years ago when I was doing some financial-based products, and I was kind of working in the C# space and having some trouble with patterns like MVVM or MVC, which when you have a really large object model, it just gets really complicated you end up with the fat controller or the fat view model pattern where everything is just dumped in one place and nothing is deterministic. So came up with this pattern called ESP to help give some deterministic updating to a model. So what is it? So it's very model-first development. So you have a model, and in this sense, it's an OO-based model. So it's not like a functional kind of pure immutable model. It's an OO object-oriented model. So you have all of the goodness that you would use from OO type of design, or badness, depending on if you're going to write spaghetti code. So you have an OO model, you have a view, and in this instance, the view would be like a React component or something like that. And you put an event router in the middle. And the event router kind of acts as a broker between the view and the model. So anything on the view side that wants to kind of change the model would publish an event to the router, and the router would dispatch the event to the model. From the model side, it kind of just can receive a stream of events that kind of dictate the changes. So there's a bit of an echo happening over there. I'm hearing myself. Oh, right. Is that the Hangouts? Yes. It's also killing my battery. I don't think there's any hardware rendering in it. Is that better? Testing? Yep. Okay. Cool. Okay. So from the view side, typically what happens, sorry, let me regress. So from the model side, usually what happens is your model will start up and it will register itself, not shown on this slide, but it will register itself with the router. So there's a router per application. So now anything can dispatch events to change that model, and anything can be notified of when the model changes by way of the router. So typically what happens is a view will start up. It'll go to the router and say, look, I'm interested in this particular model. So this is the view for that model. In an application, you might have many different models, many different views. In this instance, this is the view for that particular model. It's going to say to the router, look, I'm interested in receiving updates. Tell me anytime the model changes. And then at a later point in time, the user might interact with the view, so the React component. So they might execute a trade, or they might change some notional amount or something like that on the particular model. That will forward an event to the router. The router will dispatch it to the model. When the model will then process that change, and when it's done, the latest version of the view will be dispatched. Sorry, the latest version of the model will be dispatched to anyone who listened to it. And in this instance, it's the view. So you could have multiple observers of the same model, if that is what you wanted to. So this is kind of a similar kind of unidirectional flow that exists in React's Flux applications, where you kind of have events coming in to the system. They go to a model to be processed, new state comes out. Events come in, new state gets applied, so gets changed, and then new state kind of comes out and the view renders it. So like when React came out and started looking at that a bit more, kind of the pattern that we started using in the C# space made a lot of sense. So I ported this to JS. Sorry, I ported the ESP concept to JS. JavaScript. Okay. So just quickly I'll touch on a bit of the asynchronous workflow and how that works. I've kind of omitted the view from this, because technically anything can submit an event to the router. It could be a downstream service or a review or anything like that. So in this instance, say the user on a view wanted to execute a trade. They submit an event to the router. The router dispatches it to the entity on the model that's responsible for execution. So maybe this is trade execution entity. So it'll basically be like an object on your model. That will dispatch it to a downstream server. So typically in like really complicated applications, these massive like trading systems we make, you usually have a lower layer of services that is kind of used throughout your entire application. Maybe there's a pricing service, a booking service, session service, reference data service, all that type of stuff. And services in those type of objects that would exist in a lower layer of your application. So the entity here, which is in the model that's higher up in the top layers of your application, responsible for a screen, will dispatch a request to that service and say, look, execute the trade. At the same time, it will just toggle a flag or something on the model. Look, you're busy now. And at that point, execution flow returns to the router. It will dispatch the latest version of the model to the view, and the view goes, oh, it's busy. Show a spinner or something like that. A bit later, when the request comes back from the service pumps an event into the router. Router dispatches the response back to the entity that initially kicked it all off. And then it goes, OK, process the request, what happened, remove the busy flag, false, so on. Latest version of the model gets dispatched to the view, and and the view renders that change. So people won't think, oh, that's cool. Why don't I just use the model? Why don't I just forget about the router? Why do I bother using the router? Well, the thing about the router, it gives you kind of a deterministic flow in terms of processing your state. If you have a really large object graph with lots of different entities on it, many different entities throughout that model could potentially be entry points to change state. So maybe an entity down here has a method on it that does something. Maybe there's a read-write property up here that does something. And every time one of these methods is changed, usually your model, as it's ticking through to different states, it has to move through a series of changes. So for example, maybe it needs to increment a version. Maybe it needs to clear out some transient state. Then it needs to apply that change. When it's done, maybe it needs to validate the entire model in one shot. Then maybe it needs to do aggregations across your model to maybe compute lists of sums or something like that. And when all that's done, then it needs to notify people, observers, not people. But it needs to notify like other objects, for example. And having the router, which is acting as a broker for state change, it means you can basically serialize all your state changes by way of an event queue. And the router, therefore, can tell the model, I'm about to start processing an event. You're now processing an event, and it can go into more complicated stages if you want to build that out. Then it can say, now you're about to finish processing, and now I'm going to dispatch. So it gives you that degree of determinism, which means thinking about state changes in really complicated models becomes more trivial. You know that you're only processing that one event, and nothing's going to come in and slam you over the top, and you have to kind of worry about all these other concerns. So it's more deterministic. Okay, so that's ESP at a high level. I want to talk a little bit about immutable and mutable state. And you could probably go into a whole talk on this, but I'm just going to kind of skim over some of the points because I think it's important to discuss. So firstly, what is mutable and immutable? So immutable basically is state that doesn't change. And if you want to change it, you would create a new instance of an object. So in our Agile board example before, if you had a story and you changed the title of the story, you would create a new instance of that story. If you're talking about a mutable model, which is more typical of OO-based models, you would basically you would just mutate the same instances. So instances are longer lived. So here's that agile board that I mentioned before, and you can see that the data here isn't purely kind of hierarchical. So we have epics have many stories. A story can be done, but you can also click on the button up the top there. This little pointer. So you can click on that button and it will just show all of the stories. So the workspace has kind of a reference to stories. So let's go into how you might represent that a bit, and then we'll kind of talk a little bit the difference between immutable and immutable state, functional versus kind of OO, and some effects it has on that. So from a VDOM point of view, you might go, well, okay, I'll have a top-level component, which is my workspace view. I'll have components underneath that to display the epics, components to display the stories. Down here, I've got a details view, this guy, which is like the one over on the left where you can edit it. And then there's a modal dialog. You saw modal pop up in that animated GIF a minute ago. So you might want something at a higher stage in your application where you can kind of speak to it and it will just throw up modal over the whole page, and many different things might interact with that. So in terms of a modeling point of view, and again, if you're doing kind of functional or OO, this is probably a decent stab at what you would first need. You go, okay, I have a workspace. Workspace has many epics, and the epics have many stories, but my workspace also has many stories of the same instances. And then there's also the modal dialog I mentioned before. So if you're using kind of a functional approach, you kind of tend to have, like maybe you're using something like Redux, and things that modify your state would live in reducers. So there's a question of where do you put your reducers? Do I put them kind of, maybe you have a JavaScript module closer to the stories, and maybe they have the reducers that modify that state. It might have the default state in there for the stories. If you're using an OO-based model, you will tend to just have like a story instance, and there'll be functions on that story, or method you might want to call them, that will just receive requests and they'll update local state. So there's kind of with an OO pattern, you just put those methods on the objects. With something like Redux or a functional model, you have to decide where you're going to put your reducers and so on. So another interesting thing about this, with this data structure, which is not purely hierarchical, we've got like the workspace as a reference to many stories. If you're doing kind of a functional-based approach, you would think, where do I put the reducer that has to modify a story? Because the workspace also needs to have a story modified. So if you change like an instance, so if you change the title of the story, like you need to update the reference in the epic and in the workspace. So you could think, well, my initial stab at this before workspaces knew about stories is like maybe I'll just put a reducer closer to the story that takes the story and the request to change it and creates a new instance of the story. But then when you have workspaces that refer to the same instance, you think, well, actually, I need to move that reducer higher up in my order. So maybe I'll go to the epic, not higher. I need to go higher up to the workspace. So maybe that reducer takes the workspace, drills down into the epic to get the story, updates it, then comes back up and kind of copies that instance or something like that across to the workspace. And you're like, okay, this is a lot of going in and coming out and doing all of this crazy list lookup. So typically what ends up happening is you'll normalize your state. So maybe you'll have the stories at a higher level in your application, and the epics in the workspace might kind of refer to IDs of stories or something like that. So you're kind of limiting the scope of what you do in your reducers. With an OO model, you just tend to, the epics will refer to the same instance of a story. It's longer lived, and same with workspace. So typically you'll just dispatch an action directly to the story. It'll update itself, and nothing around it needs to get involved. So there's kind of some wins there. I mean, it's not really, I don't really want to go into like a comparison between one or the other. There's just things that are kind of interesting in both approaches. And like I said, there's a whole talk you could go into about this type of stuff. One nice thing about the kind of pure functional approaches, and this is a React specific thing, like when you're trying to implement should component update on your view, that becomes incredibly simple because you're just like, if this instance is not equal to that instance, yes, I should update the component. Whereas if it's an OO-based model, you have to kind of track that more yourself and think, like, because the instances are longer lived, so the instances will always be equal to each other. And just the final point I want to mention on this is with kind of an OO-based model, because the instances are longer lived, you can kind of, they can do a bit more things, like you can decorate them. The functions on there can be decorated with things like to help you dispatch events to them and so on. And I'll go into that in a minute. So getting events to the right place, and this is kind of an ESP specific thing. So with ESP, this would be a typical model. And this is like, going back to that agile board that we had a minute ago, this would be an example of the workspace model for that board. Takes an instance of the router. This is using a class, which is like an ECMAScript 6 thing, or if you're using Typescript, you'd have classes in there as well. Gets an instance of the ESP router, and it has some local state, which is epics. So typically, when the app starts up, some higher level bootstrap in your app will call this method observe events. And this one here just goes to the router and says, look, register this me, the workspace, with the router using this ID. And then it says, router, observe any events that I declare. What does that mean? Well, it means that you can have like a function on your model like this. So this is add epic, for example. You can decorate it with a decorator. So this is like an ECMAScript 7 style decorator. If you're using Typescript, you can get that stuff in there as well. And what this is basically saying is the router, when you call this method here, observe events on, it will scan the object, find any of these decorators, and wire up a subscription to the router. So the router underneath has a kind of an underlying observable API with this kind of syntax here. And this method just kind of hides all that away from you. But effectively what it means is anytime someone publishes an add epic event to the router, it will call this method here on your model. And as you can see in here, this workspace is just saying, well, someone's wanting to add an epic. I'm going to add a new instance of the epic. I'm going to tell that epic to observe any events. So it will wire up any events to the router it cares about. And then it just adds some local state. After the execution flow exits that method there, it will go back to the router. The router will then enter its dispatch phase, where it will update any views that care about that, and the new state will just be rendered. Okay, so let's have a look at that kind of a bit more visually. So on the right here, we've got the model, so workspace. Workspace has many epics, epics many stories. On the component side of things, on the view side of things, it's a bit more denormalized. So workspace has epics and it just has a list of stories as well, because it can, it can just take the top level model and create these stories without needing to go through epics. So if a workspace clicked, like if the user clicked something like add epic, it would dispatch an event to the router, and the router would dispatch it directly to the workspace in question. If a story, say story number 2, the user updated some state, it could just dispatch it to the router, and it will dispatch it to the story instance in question. So nothing else is really getting involved. And similarly with an epic, if one of the epics change, it can just dispatch it to the one in question. So there's kind of nothing else is really getting involved. So that kind of allows you to define changes to your model at the most granular level, i.e. an event, which means as your model grows out and you start adding loads and loads of other view-related concerns, and you just model them using events, that means this side here can also just kind of grow out without affecting anything above it. It just kind of grows independently. So you're kind of limiting yourself to some changes, which is a nice kind of side effect. Okay. Oh yeah, so just quickly want to touch on multiple teams and multiple models. So the type of apps that we tend to be building at Adaptive are like kind of quite large trading systems that are up all week. So typically we might have multiple teams working on different things. And at a lower point in your application, you might have some shared objects or infrastructure or models effectively that other teams might use. So maybe you install these via your local kind of NPM package manager or something like that. So you might have an instance of that running locally, or in a component team is developing some of these lower level models. Good examples might be like pricing models that are used by many tiles on top. Maybe you've got some region management or infrastructure that's used to kind of lay out the shell of your application. So they might come in these lower layer packages. So with ESP, it supports multiple different, you typically have one router per application, but that router can work with many different models. And as they're all registered with it, as an event is published into the router, it'll kind of process each model in turn. So you still get the kind of deterministic approach across all of the different models. So here's just saying common, so maybe this common layer here is like an NPM package that you install that your kind of framework team provide. Sitting on top of that, team A and team B might use models that interact with those. Okay, so I just want to talk a little bit about how ESP and React kind of work together and what we've been doing in that space. So there's 2 things that come in this library here, esp-js React. Well, there's actually 3, but 2 of them, router provider and smart component. So let's talk a bit about the top level bootstrapping of a typical React app, and then I'll go into these 2, router provider and smart components. So here we see I create a new instance of the ESP router. I create my top level model, tell it to observe events, which we saw a minute ago registers itself with the router. Then what you can do is you can wrap your virtual DOM in kind of a router provider, and you give it the router. And this isn't doing any rocket science. It's simply just taking that router and putting it on the React context so it's available anywhere down throughout your virtual DOM. Pretty simple stuff. There's another thing, smart component. So what does smart component do? Well, it takes a model ID, which is our workspace model ID here, and it takes a view, which is a view for the workspace. And what it will do is it will go off to the ESP router, which it conveniently gets from the context now. And it will say, look, I want to observe any changes to this model. Anytime that changes, it'll create an instance of that view, and it will pass the model down as props. So this view here will just receive props, a new model every time the model ticks. Okay. So I'm going to talk a little bit about how we can, I've talked a little bit about how we have common infrastructure and lower layer models. I want to talk a bit about how we can use smart component and some more decorators to have more dynamic component creation within our applications. So I mentioned before that router provider takes, the smart component takes this view attribute. Well, that's actually optional. You don't need to give it that. So if you don't give it that, what you can do is you can go back to your model and you can say, well, why don't I decorate my model with a binding that says, look, this model can be displayed using this particular view. This is kind of handy because it allows you to develop lots of separate business modules within your app. And you can have a higher kind of level shell, if you will, that another team might develop. And now all of a sudden your business modules can kind of just plug into that and be dynamically created. So you don't need to provide the view up at that top level. So anytime the model gets ticked, what will happen is the smart component will interrogate the model, go and grab the binding, and then just create an instance of that view dynamically and pass the router down as props. So let's have a look at why you might want to do that. So in an application like Reactive Trader Cloud, so you can see here this is running inside Chrome, and it's, there's some pop-outs and stuff happening here for the analytics module and the blotter down the bottom. So would you want, like, say if these modules were developed by different teams within your organization, would you want each team to kind of be responsible for knowing how to pop out the applications? You think, well, it's only window.open, right? That's pretty easy. But next slide, here's the same app running in OpenFin, which is an Electron variant. So the pop-out infrastructure for this is actually going to be quite different to the other one, right? See, there's no Chrome here. It looks more like a desktop-based application. So you can now think, well, what I can do is I can have these lower level infrastructure components responsible for pop-outs, for example, and using things like smart component, I can dynamically create instances of components and plug them into kind of a higher order shell dynamically at runtime. Here's just a quick visualization of that. So here was the application with 3 different regions, and these regions would be managed by models lower in your application. These regions would only have a smart component to display them. Well, they'd have some virtual DOM that wraps this, but effectively, if they have a smart component within them, all they need is a model ID from some unrelated module, and now they can dynamically create these views. So you'll have different teams working on different modules within your app, for example, and as they come along, they can register views that exist within these lower level components, which allows your separate business modules to kind of take part in a higher order shell. So, yep, so ESP packages, what do you get? So again, ESP is something that I haven't really talked about. I think this is the second talk I've done on it. We've used it kind of for the last couple of years, and it's just something that we've done before in C#, and we know that that space works really, OO kind of patterns work really well for really complicated financial products that we've been developing. We still use a lot of functional stuff and a lot of RX for our lower layers of our app that procure kind of immutable state. But typically, once we kind of go into really complicated financial screens that we're trying to develop, we're using a lot of kind of OO-based modeling because it kind of, there's a lot of goodness that goes with that. So esp-js is quite stable. It's the event router and the bindings. esp-js React is pretty much beta. I just pushed it out a couple of weeks ago, and it has these things that we've just discussed. It's just kind of a consolidating some of the things we've been using in some various apps. So that's it. These slides are here if you want to take a reference to that. Any other links? Yeah, so don't know if I've got time for questions, but that's pretty much it. Yes? No?
Brilliant, thank you. Yeah, questions? Has anyone got any questions?
No? Deafening silence. No, I'll pop this out. Yeah.
No, good.
No,
good to
any
go.
questions?
Oh, brilliant.
Yeah, cool. Thanks for listening.
Excellent. Thank you very much. Right, next up, and then we'll have a break. We've got Graham, who's going to talk about routing. I think, where is he? Oh. No, different sorts of routing.
Yeah, the router term's a bit overloaded.
Okay. Sorry. Don't worry about that.
Call it nerds.
Don't worry about
Okay,
that.
okay.
I'll just
And
clip that on.
which way does this work then?
I don't know, I think you just clip it onto your jeans or something. I think it should work. Sorry.
Oh no, it's not.
Oh, you got the same stuff.
Yes. Just did. Okay. I think I'm good to go.
It's just press it. Did you switch off the microphone?
Oh yeah. So are we good? Okay, thanks. So first of all, a big thank you to React London. Like, it's a great opportunity. I hope I don't blow it, okay? And also, hi everyone, I'm Graham. My talk today is about a new router for React called Navigation. And like I said, it's not a router like Keith just spoke about, it's a URL router, okay? So, but I can't just introduce a new router for React without first explaining why React needs one. I mean, after all, it's got the React router that you're probably familiar with. So I've split my talk into two halves. In the first half, I'm going to explain what's wrong with the React router. And in the second half, I'm going to introduce my navigation router. So you'll have to wait to the second half to find out why it's called a data-first router. OK, so here's a snippet of text taken from the React router's homepage. And it's got the odd statement on it, which you can see at the bottom, that says that the React router was inspired by the Ember router. Now, that's an odd statement because React is absolutely nothing like Ember. So, so why should its router be? Now, I do agree with a bit of the statement that says that Embers is a fantastic router. But what it doesn't say is that it's only fantastic for Ember, not for React. OK, so in order to see what's wrong with the React router, we're going to have to look at the Ember router in a bit more detail. OK, so let's imagine we built a master details application in Ember for managing a database of people. So we start off with a list of people. We click the name hyperlink of one of those people, and that takes us through to the person's details, where we can edit their information. And then there's an expandable section at the bottom where we can edit information, their hobbies. So we click the hobbies hyperlink, and that text area appears. OK, so let's have a look at what role the Ember router plays in our master details application. So the first thing the Ember router does is display a view. So when our application loads, the Ember router displays the view that matches the browser URL. So in our app, that means it displays the people view first. OK, so, and the next thing the Ember router does is change the view. So when we click the name hyperlink, Ember router displays the view that matches with the new URL. So that means it removes the people view and displays the person view in its place. Okay, and the last thing the Ember router does is change the data. So when we click the hobbies hyperlink, a parameter in the URL changes. Let's call that the expand parameter because it corresponds to expanding the hobby section. And the Ember router passes that new value of the expand item into the person view. Now, importantly, it doesn't change the person view because if it was to replace it with a fresh instance, then any unsaved edits that we'd made to the person would be lost when we expand the hobby section. Okay. So if we list the three things that the Ember router does, display a view, change the view, and change the data, then we can see a bit more what was meant by that odd phrase on the React router's homepage about being inspired by the Ember router, right? Because after all, these three things are pretty much exactly what the React router was designed around. We give the React router our components, and it's up to the React router to render them and to pass in props. But remember I said that React is absolutely nothing like Ember. Well, it turns out that these three things are actually built into React, right? So they're part of React, so we don't need the React router to do them for us. So let's have a look at how to do these three things ourselves without relying on the React router to do them. Okay, so how do we display a view in React? So we're in React now, not Ember, so views are components. So let's imagine we've got a people component that represents the people view. So how do we display that? Well, we React DOM.render it, and then React mounts the people component into the HTML container element we give it. Okay, that's displaying a view. How do we change the view? So we've got a person component representing the person view. So how do we replace the people component with the person component? Well, we React DOM.render the person component, passing in the same HTML container element. And because we pass in the same container element, React first unmounts the people component before mounting the person component in its place. Okay, and lastly, how do we change the data? So how do we change the expand item from false to true? Now, we're in React, so data props. So to change the expand item from false to true, we just React DOM.render the person component, passing in the new value for the expand item as a prop. But remember I said that we mustn't lose any unsaved edits when we expand the hobby section. Now, our inputs in the person component are just standard React inputs where their values are held in state. So if we re-render the person component with the new prop, won't we lose the state and lose the unsaved edits? Well, the answer is no. The answer is no because React knows that we're re-rendering the person component. So instead of mounting a fresh instance of the person component, it keeps the existing person component instance alive and just passes in the new props. So we don't lose any state, and so we don't lose the unsaved edits. Okay, so we've done the three things that React router was designed around, and we've done them using only the most basic of React functionality, nothing other than React DOM.render and passing in props. So now that phrase on the React router homepage about being inspired by the Ember router, that looks more odd now than it did at the beginning, because what it actually means is it means that React router is resolving problems that React already solves. And that matters. That matters because the React router's resolutions to these problems aren't as good as React's built-in solutions. You see, with the React router, we give up ownership of our components, and because we don't own our components, we can't render them and we can't pass in props. Now, I should just say there is a new version of React router in the pipeline, some of you might know, called v4, but it's even more opinionated about rendering than the current version of the React router, and so we still can't use React's built-in solutions with it. So here's a picture of the React router split into two sections. The much larger section on the left shows what the React router does that React already does, and the much smaller section on the right shows what the React router does that React doesn't already do. And we've already seen how the free Ember router inspired features fit into the section on the left because React already does them, right? So that's displaying the view, changing the view, and changing the data. But some of you might think I've been a bit unfair on the React router by making the section on the right so small. But you see, a lot of the things that you might think are React router only features are actually already implemented in React. It's just that React router can't use React's existing solutions because the React router owns our components, and so it stops us rendering them, and it stops us passing in props. So let's take as an example one feature of UI templates. It's another Ember router inspired feature, and it lets us share UI across views. And so it's typically implemented in React Router with your app component, right? That's your template. Now, you might think that goes in a section on the right as a React Router only feature, but it actually goes in the section on the left because React already supports templates. So a template in React, a template is just any component that renders a placeholder element like a div. And then what we do is when our app loads, we render the template component, and then all our subsequent React DOM.render statements, like the people and the person, we target the placeholder element in the template instead of the container element in the HTML. And that's templates in React. And you see that, again, the React Router's resolution of templates isn't as good as React's built-in solution because the React Router owns our template, and so it stops us rendering it, and it stops us passing in props. Okay, so that's the end of the first half of the talk where I've shown what's wrong with React Router. So now it's time for the second half of the talk where I introduce my navigation router. And you can see from this picture that it's pretty much the exact opposite of the React Router. So it doesn't get involved in rendering. So it doesn't have to do anything that React Router already does. Instead, it concentrates on what the React Router doesn't already do. And so let's see some of this by building the master details app you've just seen using the navigation router and the techniques from the first half of the talk. Okay, so the first thing we do is we install the navigation package from NPM. And then once we've done that, we can create what's called a state navigator, passing in an array of states. Now, there's one state for each view in our application. So there's a people state for the people view and a person state for the person view. And at this stage, we don't even have to configure any routes yet. Well, apart from the empty route, which you can see we give to the people state, just so that the navigation router knows to go to that state first. Now, with the navigation router, we don't think in terms of routes, we think in terms of states. And we can access the people state as a property on the states object that hangs off the state navigator we just created. And now when our app first loads, the navigation router navigates to the people state because we gave it the empty route. And it notifies us of this navigation by calling the navigated function that we attach to the people state. And so this is where we can put the rendering logic from the first half of the talk. So this is where we render the people component. And you can see that navigation router gives us back control over our components because it's up to us to render them. And so just to recap what's happening, so when our app loads, the navigation router navigates to the people state, calls our navigated function, and we render the people component. Okay, now let's build the name hyperlink. For this, we need another NPM package called Navigation React, and this contains a navigation link component for building hyperlinks. Now, with the navigation router, we never hard-code a URL. To build a hyperlink, we just say the state we want to go to and the data we want to pass. So when we click the name hyperlink, we want to go to the person state. So we pass that in as a state key prop. And we also want to pass the ID of the selected person. And you can see we pass that ID as a number, not a string, so it's typed. And you can see in this example, it's the number 10. And so like we did for the people state, we can attach a navigated function to the person state. And when we click the name hyperlink, the navigation router calls our navigated function, passing in the data, and then we can take the ID of the data passed in and pass it in as a prop when we render the person component. And you see, because we've got ownership of the components, not only can we render them, but we can pass in props when we render them. And the person component expects the ID passed in to be a number. Imagine we've got some prop type validation on the person component that says that the ID is a number. Now you can see we don't have to convert the ID from a string to a number because the navigation router preserves the type of the ID parameter. So it passes it in already as a number. So it passes the 10 in as a number, not a string. But imagine we've got some prop type validations on the expand prop that says it's a mandatory Boolean. Now this is currently failing, and it's failing because the name hyperlink doesn't pass across a value for the expand item. Right? But we don't want to fix this by changing the name hyperlink to pass across an expand value because it shouldn't have to know about that. So instead, what we can do is we can return to our state navigator configuration and add a default value for the expand item. And you can see we give that a default value of false. Again, it's typed, it's a Boolean, it's typed. And now our prop type validations are all passing. And so when we click the name hyperlink, it calls our navigated function, pass it in the data, and we render the person component passing in the two props. And we know from the first half of the talk that React then unmounts the people component and mounts the person component in its place. So next up, let's build the hobbies hyperlink. So it's very similar to the name hyperlink we just seen. We still want to say we're going to the person state, and we still want to pass the ID of the current person. But this time, we also want to pass a value for the expand item because we're expanding the hobby section. And you can see, again, we pass that typed. So it's typed as a Boolean. It's typed as true. It's not just a string. And now we don't have to change the navigated function attached to the person state at all. That's exactly the same as the navigated function you've just seen. And that's because when we click the hobbies hyperlink, the navigation router calls our navigated function, passing in the data. And we know from the first half of the talk that we can safely re-render the person component, passing in the props, and that React will keep the existing person component instance alive along with all its state. And so we won't lose any unsaved changes when we expand the hobbies, when we click the hobbies hyperlink. Yep. Sorry, I've gone the wrong way. Okay, so now with that, our application is working. So all the hyperlinks work. You click the hyperlink, the right component with the right data is always shown. But how can our application be working when we haven't even configured a route for the person state yet? Remember at the beginning we gave the people state the empty route, but we didn't give the person state a route. So how can the hyperlink, like the hobbies hyperlink or the name hyperlink, be working when there's no route? So you see, the thing is, the navigation router generates temporary URLs for us. So here's what the URL looks like for the hobbies hyperlink. Now, it's a bit of a mess, but that doesn't matter because, like I said, this is just a temporary URL that we can use throughout development. And now that our application's up and running and working, we can change that messy URL into this clean URL without changing a single line of code, just by changing the configuration. And this is what I meant at the beginning of the talk when I said that navigation is the data-first router, because what we do is we can get our app up and running, passing type data without worrying about URLs. And then once our app is up and running, we can change our URLs to be whatever we want without changing a single line of code, just by changing configuration. So let's see how to do that. Let's see how to change the messy URL at the top into the clean URL at the bottom, one step at a time. And let's start with the 10, because we can see in the clean URL at the bottom, it should say 10. But in the messy URL, it says 10, 1_2. So what are those funny characters at the end of the 10, and how do we get rid of them? So remember that navigation router passes type data. So it passes 10 when we selected the person. It passes that as a number, not as a string. But how can it pass it as a number when URLs are just strings, right? So what it does is it stores the type of the parameter actually in the URL itself. So that's what those funny characters after 10 are. That's saying that the ID is a number. Now, so we can remove those funny characters by telling the navigation router what the type of ID parameter is. So here you can see we've gone back to the state navigator configuration, and we've said that the type of our ID is a number, and now the navigation router doesn't have to remember it anymore. And so that produces a cleaner URL at the bottom, where the funny characters have been removed from the end of the 10, and you can see it here. Now, we don't have to do the same for the expand parameter. You can see that's got no funny characters on the end, and that's because the navigation router works out the type of the expand parameter from the default value we gave it. Remember, we gave it a default value of false, you can see here, and so it knows it's a Boolean, and so it doesn't have those funny characters on the end. Okay, so let's carry on cleaning up the URL, and let's make it begin /edit instead of /person. Now, by default, if we don't give a state a root attribute, the navigation router uses the key of the state as the name of the root. And so that's why it began /person, because we didn't give the person state a root. And so now we can fix that just by assigning a root attribute of edit to the person state, as you can see here. And that cleans up the URL and changes it to begin /edit. Okay, so we're going to carry on over the next few slides cleaning up the URL. But these upcoming changes are all just going to involve changing the value of the root attribute that we just created that currently says edit. So on the next few slides, instead of showing the whole configuration, I'm just going to zoom in on the root attribute just to make things clearer, but it sits within the whole configuration. Okay, so next let's make the ID a root parameter instead of a query string parameter. So by default, the navigation router passes all data in the query string, but we can change that by using the curly brackets notation to denote something as a root parameter. So you can see here, we denote the ID as a root parameter, and that cleans up the URL, and it moves the 10 over from being a query string parameter to being a root parameter. And just to be clear, after each of these changes we're making on each slide, our application's still working. We don't have to change a single line of code. All we're doing is changing what the generated URLs look like. So next up, let's make the expand parameter a root parameter as well instead of a query string parameter. So again, we use the curly brackets notation like we did for the ID parameter, and that makes it a root parameter. But this time it's a bit different because we mark it as an optional root parameter using the question mark there. And the reason we have to do that is even though we're working on the hobbies hyperlink, we mustn't forget about the name hyperlink. And remember, the name hyperlink doesn't pass across a value for the expand item. And so that's why we mark it as optional. So we're doing well. The URL is pretty clean, but there was one extra stage we wanted to do. We want to get the word hobbies between the two parameters, between the 10 and true. We want the word hobbies in between there. Now, we can't just put the word hobbies in the root attribute, because although that would work for the hobbies hyperlink, it wouldn't work for the name hyperlink, right? Because the name hyperlink, we want that to be /edit/10. So what we can do is we insert a plus after the ID parameter. You see that before the hobbies. And then that effectively creates two roots for us out of the single root attribute. So it creates one root to the left of the plus that works for the name hyperlink, and then another root with the two parts taken together that works for the hobbies hyperlink. And so that creates the clean URL we were after at the beginning there. And we've done that without changing a single line of code. So we've gone from that messy URL to that clean URL without changing a single line of code, just by changing the configuration. And almost all the changes were just to the root attribute value as well. So imagine if we were using the React router and we wanted to make those same kind of URL changes. We'd have started out with a flat config, ended up with a nested config, and then along the way, we'd have had to create a brand new hobbies component just to represent that nested configuration. So you see, like nested configuration is another Ember router inspired feature that you don't need when you're using React. Okay, so that wraps things up. I don't know if that was 20 minutes, but I probably spoke a bit faster than I did when I was planning it. Might be 20. So here's a link to my navigation router documentation. It's a GitHub pages site, so it's my name, grahammendick.github.io/navigation, and there's lots of docs and lots of JS fiddles, so you can see it in action. And I've also created a JS fiddle to go along with this talk as well. So that shows the master details application that we've just built up and running, so you can see it and have a play with it. Anyway, I hope that you liked it anyway, and thanks very much.
That was brilliant. Thank you. That was really, really good. Does anyone have any questions for Graham?
Yeah, great work. I love it.
Oh, thanks very much.
And my question is, which types does it support for the query string or URL parameters?
That's a great question. Thanks very much. So it supports string is the default. Then it supports number, Boolean, and date. And also it supports arrays of those types. So you can pass an array of strings, an array of numbers, an array of dates, an array of Booleans. And the interesting thing about the arrays is that by default, remember, everything's passed in the query string. So if you pass like an array of numbers, it would be x equals 1, ampersand x equals 2. You with me? But if you then configure that array to be a root parameter, it will then make that 1/2. It will be like a splat. Does that make sense?
Yeah.
Does.
Cool.
Okay.
Yeah, awesome.
Nice one. All right. Thanks for the question. Yeah.
Hi. Yeah. Great work. I wanted to know if it works on the server.
Yes, it's isomorphic. Yeah, that's right. And that's another good question. Thanks for the question. Much appreciated. So it's in the documentation link that I sent you, there's no examples, obviously, of it working on the server because it's just runs in the browser. But in the source control, in the GitHub, I've got samples of it working on the server. So I've got a sample of it being server rendered. I've got a sample of code splitting and server rendering, if you're interested in having a look at that. And
yeah, because the question was like, as it is data rendered and you get URLs on the server, how it actually does the matching of the route.
I think I go and say that one again, just.
So as it is data first, but in the server you get URLs. I was wondering how the matching is done.
Got you.
on the server.
Okay, so when I say it's data first, it's still URLs, but you don't really have to worry about the URLs. So if I go back to, I don't know if I can do it at the moment, and let me just see if I can go back. Yeah, so that's the URL. If you don't configure a URL, there's still a URL behind it. It's just your, it's just you're passing it as type data, so you don't have to worry about it. So if say you didn't configure any route or anything, on the server you'd get that URL. Obviously it's a bit of a mess, but that's totally fine. Throughout development, you've got proper URLs, and you just don't have to look at them. You know, it would just like work. And then if you want to, you tidy it up, and it works just the same. You don't have to change any code whatsoever. Does that make sense? Yeah. Okay, cool, thanks.
Great. Does anyone have any other questions? Yeah.
Hey, yeah, great talk.
Thanks.
Did you, or do you have any benchmark? What's the overhead of all those transformations that you do? And do you have any benchmark against, I don't know, any React router or any other routers?
That's a good question as well. Just to be clear, there's no, I haven't, is in the short answer, but in the longer answer, I'm very concerned about performance. So when it's building like the URLs, there's no regex involved. You know, it's just flat, just making strings and just plussing them together. So there's nothing funky going on when it's building URLs. The only time like regex, like slow comparison for routers, that's a classic slow bit in a router. That only happens when it's passing it. And that happens once, you know, when you click a link, then you pass it once. But in terms of building URLs, it's like just string plussing and, you know, does that make sense?
Yeah, yeah, thank you.
Thanks. But I think I will take that on board and get a benchmark out of it. So thanks very much for the question.
Anyone else? No. Great, thank you, Graham. That was brilliant.
Okay, thanks.
Right, we're going to have a 10-minute break, which will probably be 15, because that's what happens. And then we've got Alexei's doing
Теперь здесь зеленая кнопка. Можно выбрать как бы какой из экранов. Вообще, я думаю, что он будет шарить только один экран за раз. Можем попробовать посмотреть, как.
Давай посмотрим, что происходит. Тут проблема в том, что если я его начну play, то как бы у нас все, мы locked. Да? Мы ничего не...
Ничего не шарит. Мне кажется,
У нас есть preferences? Вот. По-моему, для этого мне нужно подключиться к другому экрану.
да, тогда тоже там все переключится.
А, да, и скорее всего там будет второй.
Да,
Мы
да,
давай попробуем, что ли? It's all right. Really nice talk.
Thanks.
Really impressive.
Oh, sorry. Thanks very much.
Cool.
I think that's my hangout. Feedback.
Feedback.
Yeah. Good luck with that. I know you can do it.
Thank you. I hope so. So, где она? Какая она?
С другой стороны.
Ага. Так. Так, ну что? Теперь надо понять.
Окей, собственно, ты можешь попробовать расшарить.
То есть это у нас, значит, mirroring нужно выключить. Mirroring options. То есть это я могу сделать вот так. Тут у меня остается. А, нет, они мируют сейчас, мне кажется. Что? Так. Вот. Отлично. Теперь это у меня эта штука, да?
Теперь, мне кажется, ты сможешь выбрать.
Ага. Так, scale, enable presented display. Так. Это на каком экране будет? Отлично. А теперь можно посмотреть. А, я же могу отсюда выйти. Серьезно?
Ты можешь попробовать активировать скриншеринг теперь. Теперь, думаю, выдаст сейчас скрин 1, скрин 2. Ты можешь попробовать угадать, который из них.
Мне нужен этот? Попробуем?
Давай.
А как мы увидим?
А теперь активируй презентацию, и я могу посмотреть, что именно.
Давай.
Yeah. 2 seconds. We've lost the speaker. We're gonna go and find him. Okay. Hi. No, sorry. No, don't read daft. Right, hello, we're back. Thank you. So this is Alexei from We Are Goat. He's going to talk about type systems. It's going to be cool, I think.
Okay, can you hear me? All right, so I'm Alexei Gorev, work in a small studio, We Are Goat in London, and we're doing apps for brands and brands for apps, and other fancy stuff. My subject is not as fancy as the previous two talks, not as exciting, but again, I think we will get through it. So my first idea was to actually show Flow in its entire beauty. Talk about setting up and all this, stuff, compare it to TypeScript. But then I figured that the main discourse at the moment is not about TypeScript versus Flow, but rather is, do we use static typing in dynamic language, which JavaScript is, or do we need it at all? And normally when you go into like the forums and you read something, it's all about, static types are cool. Look what you can do with TypeScript or Flow, and, go pick one. And your normal reaction will be like, that's amazing, back to work. Because, you have stuff to do on Monday or whenever. And type systems are, they're nice, they're beautiful, but like, do we need them? So the talk received a rather ambitious title, On Types and Typing in JavaScript. And we have a plethora of double-barreled names in computer science and maths when it comes to typing, like Hindley Miller and Curry Howard and all those. I'll throw another one, which is very, very useful in the context of static typing in JavaScript. It's Kubler-Ross. I don't know if you've heard it. This lady in the 70s, she introduced a system that a JavaScript programmer can use when he's, facing static types moving towards him. And there are several stages. They're quite well known. The first one is denial. And when this tell us, static typing is very good, and you can type your stuff and there are no errors. Yeah, we're not in Haskell, are we? We have side effects of functions are not that pure. And what we use historically, beginning with a small talk and S unit and whatever, we use DDD. That's a silver bullet, kind of. And we know that static typing in dynamic languages is insufficient. So we need unit tests. And if we need unit tests, then type checking is redundant. Because we already covered everything. What's the point? And moreover, some static type checkers, or actually all of them, technically, can reject working programs. It works. The runtime doesn't really throw an error, but it will be, you will be yelled at by a static type checker. So they're considered harmful. Then we'll come to this thing, JavaScript is untyped. Technically it is, but it isn't. I mean, every single JavaScript engine actually has a way to figure out your types in runtime. But there is a term unitype, which is very, very famous now, because technically you're just dealing with one type. All the values that you can have in JavaScript is one type, and then runtime tags it. But is it a good mental model to program with? Like when you are writing your code, is it good to treat your string the same as your number? It's madness if you think about it. When you write it, you kind of, this is a string, this is a number. So mentally, the unityped idea doesn't really help. And my unit test. That's the kind of the next thing. How many of you, by show of hands, actually have 100% coverage on all of your applications? Okay, 80. So we're in there together, you know. We're not we're not Uncle Bob's, yeah. I'll give you the link to the list of list of links that I used when I was doing this presentation. And there's a nice article by Uncle Bob saying that basically if you have 100% coverage, you don't need static types. But we're not Uncle Bob's, so you know. So unit testing is not it's not that I'm saying that unit testing shouldn't be used when we're using static typing or other way around. It's just they kind of come at different angles to solve almost the same problem, the correctness of your program, and refactoring. Okay, you have mocks everywhere, so refactoring is still a pain. So, and yeah, I prefer when I use open source libraries, I prefer libraries that are covered with tests. I'm very hesitant to use something without unit tests because you go there and you don't see tests. It's like, wow, what if it doesn't work? Well, that's part of the problem. What if it doesn't work and you will have to fix it? You go there and good luck with figuring out what's going on because let's be honest, we don't normally have time to document our open source libraries. We have a bit, but then kind of everything else is just there. So unit testing is actually a good source of documentation. It's always types, huh? But anyway, there are good quotes about TDD and type checking and kind of the difference, and then of course Bordeaux, like that's quite obvious. She had another tweet saying that you shouldn't put yourself in a position where you need to choose between static typing and testing. It's a thing that you should use both. So that's taken from the repo over there. A test of something to actually be a function. We shouldn't be testing those things. We're big on testing on kind of for functions. Just it's one of the main thing in every test suite kind of starts from that. Is-array is a nice one as well. And yeah, one important point, it wasn't taken from the inner kind of test that relates to something that you get from the outer world, so the runtime. It was taken from a thing that actually is array straight from the beginning. And the thing is, with this, you kind of have a documentation for the user, the consumers of your API, right there. And if they use Flow and you're using Flow, they're gonna have an auto completion for that. If you use TypeScript and they use TypeScript and the same. If you're on different size, it's a bit trickier, but the person who uses TypeScript can actually quickly sketch up the types based on Flow types, and they are different in certain things, but not that different. So then I actually figured out the difference. We show the presence of certain behaviors in our application by writing tests. We're actually showing absence of certain behaviors by doing static type checking. And so there's no fight, like it's just two things going together. Well, let's go to stage 2. Anger. I'm gonna quickly go through it. There are things you just see when you go through through core or whatever, and just that's actually the beginning of this. Typecasting errors. This is a good one. Probably an experienced C programmer. Anyway, the next one is bargaining, obviously. We're getting there. And the last one, I mean, put the asterisk there. It is one of those, but so there are a plethora of things like Type.js, Context Coffee, whatever it is, and Treat.js. They all do also called contracts, and you basically write your specification of types you think your function uses or your value is, and then it transformed into a runtime check. Basically, it's a nicer way to write invariants. It's still runtime, so you get shot in the face when you're running your application. But it's good. Some of the things are using Sweet.js, which actually, how many of you are using Sweet.js? The macro thingy? Yeah, I thought so. Have you ever used it? Like, how many of you? How was it? Years ago. All right. So yeah, I mean, yeah, because it wasn't compatible with Babel at some point, so it's just okay. So some of them are using it. So nice. You can write your type signatures and stuff. Be like, you can pretend that you're a Haskell programmer, write nice kind of things with like arrows as if it's carried, but it's not. It's a it's a nice thing. Kind of feel good about yourself. Yeah, the prop types is the same thing technically. We have context types. We can't really avoid those. If we're going deeper. But the prop types technically is just a runtime way of checking your types and variants on types. And Flow, for example, and I think Typescript as well, can actually use your type definitions to tell you that you're not providing specific props or correct types of props when you're actually writing your code and you're using your JSX. It just can tell you're not providing it. And very nice. Depression. I was looking at OCaml at some point. I was watching this presentation. I think it was there, and it was Yaron Minsky from Jane Street. And said in OCaml there's always two of everything. Two core libraries, and one of them is actually Jane Street's. But anyway, but we're better than that. With JavaScript, we have more. So yeah, the depression comes from like, okay, well, what am I going to use? And if I'm going to use it, how long it will be before the thing will disappear? And so it's actually quite easy. I mean, we can remove those because we're talking about JavaScript static typing, and those are amazing, but those are not JavaScript. And TypeScript technically should fall there. I just don't want to put it there because then the argument will be just, there won't be any argument. You came here for that. But basically, Elm is amazing. PureScript is insane. ReasonML, young but amazing. BuckleScript just, have you tried BuckleScript? That's amazing. You can't. It's unbelievably good in generating readable JavaScript. Like, it's the first time I've actually seen something generated from a compiled to JS language that is not only readable, but it's actually nice to look at. So yeah, BuckleScript is pretty amazing. And all of those, Idris, the brave ones of you. So anyway, so kind of this we can take out. Those two, they're immature, quite nice. They're both written in Haskell, as far as I remember. Both are actually, no, Inferno is just an inference engine. It just does it without any annotations. Pretty powerful, but again, immature. JSX does it with annotations close to Haskell. I think the same with kind of arrows that kind of hint that is a curried function, but it's not. But anyway, everyone wants to be a Haskell developer. So we get to two of them, I promise there won't be any fighting. So, I mean, it's quite obvious from the numbers. Like, Flow is 2 years younger, So you can expect the things you get from Flow. But it's quite surprising. What I like about it is the 8,000, almost more than 8,000 stars. Granted, this is a camel, which is, if you think about it, it should be less, because the main argument of people who want to contribute to Flow is that, well, it's not written in JavaScript. How would I contribute? Well, those 8,000 people can. It's not twice as it was the TypeScript. But anyway, so TypeScript on 12, the first one of them, I was impressed. I looked at it and said, ooh, I don't need it. And written in TypeScript while, the bootstrapping. Definitely typed is the source of all the third-party lib definitions. Loads of stars, loads of forks. Flow 2 years later, written in all camel, which that's my opinion, I like. The fact that it's written in all camel, because in this whole pipeline of type checking, there's one strictly typed language. The main resource to get your lib definitions is Flow typed, not as fancy as definitely typed. Less stuff there, still quite good. The main argument in this fight of TypeScript and Flow, which isn't a fight, but you see them, is that there are more definitions for TypeScript. I looked at them, and yes, there is more for TypeScript, but not the quality of some of the library definitions is actually, it's kind of diminishing the whole benefit, because sometimes I see things like that. It's pretty much like, it's just like, yeah, it's fancy, it's cool, you write types, but there's like any, you type as any for anything. This is not official definitive types. The definitive type one has this. It's a bit more complex. Do I have a thingy here? Ooh. So, how many of you using Redux? Nice. So my problem here is this. I mean, those are generics. It doesn't really matter if you write TypeScript or whatever, or the dispatch for some reason has a type parameter that is actually the same as, which is, it's a state. How often do we have something to do with state in dispatch? Yeah, that's the thing. It's a hidden thing. So why do I have it there? This is an official, like, it's not official by Redux, but it's the one that you use when you use TypeScript with Redux. Pretty sad. And then the reducer, for some reason, doesn't have a dependency on the action. And the action just comes from just somewhere. So anyway, so it is problematic, because, yeah, you have loads of them, but we need quality. And yeah, just to remind you that there's no, like, there is the state going on, but we don't really care about it in terms of types. This is it was released 2 days ago, so it's quite new. This is the official Flow definition for Redux. And, well, you can see it's quite sane, Reducer, store, the dispatcher, everything kind of makes sense. This is a peculiarity, but, it's nice. So, okay, I'm running out of time. We need to get to the acceptance. The differences, very important differences when you come to the static pipeline, that's TypeScript structural typing for everything. Everything is structurally typed, so your classes, whatever, they are kind of, if they have the same structure, they're accepted everywhere. It's not that it's bad, it's just up to your intents. If you like it, then okay, it's your thing. If your application is dealing with structural things mostly, because most of the functional languages are like that, it's a structural typing thing. Most of the OOP languages are nominal, where it means that if your class person and class user have the same fields, they're not equal if it's nominal, but they're equal if it's structural. Flow is structural for objects, interfaces, and functions, but nominal for classes, which kind of gets you some interesting effects. And it works with variants, which I'm not going to get into at the moment because, again, it's a long thing. The presentation will be online because the variants will basically protect you from certain behaviors that you can put in your application. TypeScript has the point where they use bivariants, like everything is accepted everywhere, because most of the JavaScript programmers are already doing it like that. But it's not necessarily a good thing to do it. Code examples, anyway. There are some flow extras that are quite nice. There is an existential type, which is basically you put this asterisk there, and it's almost like saying any, but any, you get any. If you put existential type, the flow will try to infer what's going on based on the context. And yeah, the main difference actually is flow has a much powerful inference engine. It actually infers your types without you annotating your stuff. Quite often, most of the times. It has async await, which TypeScript doesn't, but then again, next release they will. They're kind of going like that. So you would expect the TypeScript will come up with something insane, and then Flow will come up with the same thing, and they could continue going like that. I mean, competition is quite nice there. Again. So, but the most important thing is if you look at because we're all big on looking at like, oh, whoa, who uses this thing in production? If they're using it, I'm totally using it. Does eBay use Node.js? I'm totally using Node.js. So basically, TypeScript is the kind of big players. Angular, it's important. RxJS, Visual Studio Code uses TypeScript. It's written in TypeScript, apparently. Apollo Stack is amazing library for GraphQL. I mean, if you haven't checked it out, check it out. It's very good. It's written in TypeScript. And the other day, I was trying to mock one of the things in Apollo Stack for testing, and I went to the repo and tried to check. I was like, oh my god, I'm not going to look at someone else's code, and I'm not going to understand anything because they're 100 times smarter than me, and they write their code in a good way. And I opened it, and I understood everything. It was, there were types everywhere, and I could just follow the types and understand how do they have everything structured, and what kind of data structures they have, and how they're using them. I was impressed. I was like, literally the first time I could understand everything well in someone else's code. Flow has less of a big names there, and like Discord and Pinterest they just tweeted that they use Flow. I haven't actually seen anything from them before. And obviously all the Facebook stuff uses it extensively. Data loader, Jest. So yeah. So the point of the talk actually is not who's better, and why should I use Flow over TypeScript? Although I use Flow, you might actually find TypeScript more comfortable for you because of specific things, because of the structural typing, or less kind of invasion into your code in terms of type inference. Maybe you just want to actually annotate all your types and just go with it. It's not as good. You want your type checker to be in a way kind of smarter than just a compiler. It really depends on your needs, but one thing is very important, that types are, as I mentioned with the Apollo Stack, they're very good for documentation. This documentation doesn't get outdated because if it gets outdated, then it means the application doesn't work, because the types are there, they are connected to your code. As well as the TDD thing, you didn't update your test, or you didn't really write the test for a new feature, but the types are there. If you go on typing your stuff, it's a good thing to document. We also get some, in terms of flow, I haven't really researched in terms of TypeScript, but we get some tools for analysis, which we should discuss, because basically flow infers more than just a type. They keep things around for some other things. And in fact, last week I discovered a thing called suggest, which basically, if you type flow suggest, it just goes through your file and suggests all the types for you. And you get the source code with all the types. So you can work with it almost like an iteration based. When you actually don't know the types for your function, flow suggests you something, you correct it, and so on and so forth. It's a tool for you. It's not really in any of the editors, so you have to put the commands into command line, but we're not scared of that. And I think the editor support will get better. It's perfect for TypeScript in Visual Studio Code and in Atom, in what's that? The big one, WebStorm. But the recent early access preview of WebStorm actually introduced Flow. It's pretty good. Check it out. I mean, works. So we have like almost the same thing for all the editors. And again, it's pretty impressive when you start working with Flow and you, for example, use Draft.js when they actually they finally exported their types, and you start typing something, and without going to see the documentation, you actually have your documentation just there. You know what methods are there and what types those functions are, so you know what things to use there, and you don't have to always, okay, this is a string. No, it's not. And you go there and you're just like, okay, this is a string. So it just tells you that, and it yells at you if you actually using something wrong. And if the API changes and you just pulled a new version for some reason in your production code, you actually can see what things are changing. So yeah, and besides correctness, it's actually, again, I'm just preaching. I think just start using anything, so the libraries are more documented than they are now. That's just a very good way to document it. Just kind of try it. I'll just end with this. And yeah, I kind of fixed I fixed my slides because I noticed that my presentation was kind of all the headers were just here. This part, I noticed that it's just a dead end. So my last slide, I just didn't check it, just like that. Moved it up, but thank you very much.
Thank you very much. Has anyone got a question that they want to ask?
Hey, do you do any runtime type checking at all?
Sorry?
Do you do any type checking in runtime?
Well, we're doing stuff for context, obviously, because there's no other way. Prop types, rarely.
But like, if you work with an API, for instance, do you just assume that the response complies to the interface?
No, that's kind of basically, even if you use API, even Flow or TypeScript will actually assume that there are like some nulls there, whatever. You assume the worst, and then your type engine will tell you, check for them. But that's one of the things actually, because you assume there's nothing there. You put them as all nulls. Kind of they can be that or they can be that. But it's a good thing to actually document what can be null, because you can see what you can receive, and then you test for those things in runtime.
Who's next? I saw some other hands go up. Yeah, there you go.
So given that TypeScript and Flow are both incompatible, they've made design decisions that are different on things like nominal versus structural, and also the fact that at the moment it's still a question for a new project, a new company, which to choose. Do you think that the differentiators can sustain this position where both have their individual advantages and they're both legitimate, or do you think that one will have to win out?
To be honest, when you're starting a new project and you have a big team, you need to go around and actually ask everybody, are we going to use like strict and static type, checker. In this sense, Flow is less intrusive because you basically don't have to do a lot and change a lot. You don't have to use specific type of a file. You don't have to, because TypeScript technically is a compiled to JavaScript language. Because it has structures that JavaScript just doesn't have, as enums and other stuff. So I think if you're starting a new project and it's like just scary, then Flow will add some stuff to you, and has an eject button as well because of that. If you're halfway through a TypeScript project, you basically, it's very hard to go back and say, we don't need types, just eject. With Flow, you just basically run it through Babel. It removes all the type annotations, and that's it. Free to go. Because, again, TypeScript will change the code you write, because it will transpile it. And I think, I'm not answering your question, actually. Yes, it is a bad thing that they're incompatible and basically that you don't know what to pick. But you still have to, TypeScript won't change into nominal typing because that's a design decision. There is a white paper supporting it. That is like, it's done. So the only way is maybe Flow will change their decision, which it's not going to happen either because there's a specific decision. So, and it's just up to you to choose something. I don't see, there are talks about, moving them together, but they're just too different. So I think, it will be either or. And the library managers and maintainers probably will just do libdefs both, which is not the hard thing. You don't have to write your library in one of them to actually have definitions for your users to actually use it. So, it's not bad. Did I answer your question in a way?
Good enough. Thank you.
Anyone else? Another question?
So I personally use TypeScript, and on the server side, I don't use JavaScript at all. So I have another language, which in my case is C#. And for the API, I generate the types. So the TypeScript definition, I generate it from C#.
Mm-hmm.
Are there similar things for Flow for various languages, where you can take an already static language that you use on the server and compile or generate the Flow interfaces for that?
No, I haven't seen. There might be, but I haven't seen any of those. It's a nice idea, though. But no, I don't know any of them.
All right, thanks.
Has anyone seen any? No. Who uses TypeScript and who uses Flow? Right, it's TypeScript first.
There's a TypeScript, yeah?
Yeah, 1, 2, 3, 4, 5, 6, 7, 8. 8 TypeScript. Flow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wow, it's quite close. Do you think we should be using them more? We should, shouldn't we? I think. I don't know. Half of me thinks, I spent 15 years in a strongly typed environment, and you have this beautiful dynamic, well, so beautiful dynamic language, and then you want to put it back in a box, and you kind of like resisting it a bit. But I think it does help. But I'm going to have a T-shirt that says "Flow is as far as I want to go." Right. Okay. Thank you very much, everybody, and thank you for the speakers. They've been brilliant. Don't forget to submit your proposals for talks for the conference, and to get a ticket on the 7th of October. And yeah, thank you very much for coming. Thanks to Skills Matter. Cheers.